Okay, so now we're going to do a linear analysis of our geometry that has a 2D planar mesh with quad elements. And so like I said before, I might have said before, I'm just going to turn on solid elements because I think it looks nicer. And so the first thing we're going to do is set our geometric properties, and for all our analysis in Mark we're going to be doing plane stress just because of the stress acting only in the XY direction. Or sorry, on the XY plane. And so, yeah, we're just going to rename that, add all our elements, and hit OK. And the next thing, just going to check to make sure that it's good. And so the next thing we're going to do is turn on our materials. And so we're just going to be working with 6061 aluminum today. Let's set the elastic modulus here, as well as the Poisson's ratio, just so the finite element analysis software can calculate the displacements of all the nodes. Apply all that, hit OK. And moving on, next we're going to set our boundary conditions. And so we're going to fix the translation in the x direction, just so that when we're pulling on the end that has the smaller height, there's the whole geometry won't be moving along with the force. And then we're also going to fix the y direction just at one node, so we don't have any rotation that misrepresents what's actually going on when we add uniaxial tension to the plate. And just going to turn on the solid elements just because they're easier to see just with this click of this button. And yep, just changing from wireframe to solid. Okay, and lastly, we're just going to apply a point load. Just name it P point, and so we're going to apply that in the x direction. Like I said, uniaxial tension on this plate. Just add these nodes, and we're going to do a 100 Newton load. But as you can see, there's a number of nodes that we have to take into account. So let's do 100 divided by the number of nodes. Good there. We could also apply an edge load and just do the number of edges or a pressure. And so let's go ahead and run our job, hit linear elastic, change the name for this one. Make sure our initial loads are on, make sure we're not translating the x or the y in the one node, and our p load is applied. Also change to plane stress since we're running 2D analysis. And in our results, we just kind of want to look at the stress and the equivalent of stress to compare to our analytical calculations. And so make sure we got all our results good. Check the analysis, make sure it's going to run, and then let's submit and run. Oh, it didn't like when I didn't use underscores the first time. Alright, let's submit. So it'll take a couple seconds. Okay. Let's turn on the contour bands to see if we get that nice stress distribution that we can expect with filleted plate. And yep, it looks good. And we're going to move on into some post-processing after this.